Good evening, friends. Welcome to Eastern Academy. Good morning, friends. Welcome to Eastern Academy. And today we're going to discuss about understanding 8085 microprocessor, week 4 and session 1. The first week we discussed about the pin details, and the second week we discussed about the few instructions, and third week we discussed about the how to do programming. And today we're going to discuss about once again a few more instructions. And if anybody have any doubt, you can ask me in the beginning. And as I told you that this is not a very serious formal type of session. I want you to understand that's it. So, and as you know that 8085 has about 240 or 250 instructions. And most of the instructions are all similar, very similar. For example, let us take a case of we discussed about move. Actually, it should be copy, but they have written move. You're not moving. You are actually copying. Move A, comma B. That's one instruction. Move A, comma A. That is, it starts from there. Move A, comma B. Like that up to move A, comma L. C, no, C is not there. A, B, C, D, E, H, L. You have 7. And think of it the same way. Move B, comma A up to move B, comma L. So this we discuss. We all know about the move instruction. If you see this one, you have how much? 7 into 7, about 49 instructions. About 49 have gone. Understand? About then we have an instruction called move immediate A up to move immediate L. That means that you can move any number into the no. You can only set carry. There is only one instruction is called set carry. You cannot set other things. You can set only a carry flag of the instruction. You cannot do anything. There is a method is there. I will tell you one thing. I'll tell you. We do the same question we used to have a doubt, and there is a there are 2 instructions. One is called push PSW, pop PSW. Understood? Push and pop. That using this instruction we do that. I'll you think of it. I'll when I discuss about push and pop, I'll explain to you. There are methods. Okay. Okay, so now move instruction is gone. Like that, we have an add instruction. Add carry. Subtract with borrow. And or XOR. Am I right? Compare. Each one is having a add B. B to L. B to L. B to L. Sorry, A to L. Sorry, A to L. That means that I can say add L. That means that A plus L to A. Okay. If I say that or A to L or H, that means that I will do A or with H and put the result in A. We take A as always a reference. I say compare. I will do compare A, for example, you compare A and H or A and D. I'll compare A and D. Okay, I will not see. The problem is in the other cases, add, carry, subtract, borrow, and or A, XOR. In all the 7, the A will get affected. But in the compare, A will not get affected, only flags will get affected. Okay. Now, this is what about how many you see that? A, B, C, D, E, H, L. It's about 7. So 1, 2, 3, 4, 5, 6, 7, 8. 8 into 7, about 56 instructions are gone here. Am I right? Like that, once again, add immediate number and add carry with immediate, subtract immediate, subtract borrow with immediate. That means, see, what they are trying to do is very clear. Please understand, they want you to remember the things without too much of pain. That means that you can add any registers A to L with A. What are the operations? Move, add. Sorry, not move, forget about move, we discuss. Add carry, subtract borrow, subtract with borrow, then X and or XOR. See that you have about 1, 2, 3, 4, 5, 6, 7. A, B, C, D, E, H, L. You have about 7. You can do all this operation. See, A, B, A. You see that? All the combinations are possible. Only thing is you have to try it out. Yeah, compare is only for flag change. Yeah, compare will change the flag. Otherwise, no meaning. You will do the compare and take a decision. You will compare, then you will take a decision, jump if 0 or not 0. You will take a decision. Compare will change the flag. Okay. So those are all information. See, the problem is, no, I don't understand what is how. I need to understand about what is how meaning. It is not me. I'm not doing it or nobody is doing it. It is a 80-85 microprocessor that manufacturer has told. That manufacturer has told, if you do compare instruction, you'll change the flag. What they do here is very clear in the compare. When they do compare, they subtract from the temp instruction a register with the other register B. They do subtraction. Actually subtraction is taking place when you do comparison. So the flag will be set. So that is what there's something called how and dot. These are all told by the manufacturer of the chip. That's the only thing. So that's the only thing. The chip manufacturer has told you that it will affect the flag. That's it. Then you have to go and refer the data sheet. Let me see that. Let me share the data sheet of compare and see that what it says. Immediately we see that. Let me take a data sheet of let me refer the document immediately. Okay, so you want to compare what the compare instruction that they mentioned it here. They will say that what is the here. See here, compare memory. Sorry, compare yum. This is I don't remember this thing because it's all a simple concept. See that there is a thing called compare register. Okay. See, the Z flag is set if 1. The carry flag is set if A is less than R. Am I right? It has both the flags set. Z flag and the carry flag will both get affected. That is what the manufacturer said about this one. What? So we'll refer. Whenever we have a doubt, we can go back and see the documents sent by the manufacturer. So, like that, there is one more instruction is there that is called, we have discussed about and. If you do and A, B, let us take a small instruction and move immediate A, 79H. Okay, move immediate B, 48H. You say or and, let us say and B. The and B means A and B, the result in A. Now, what is A? 79. 0, 1, 1, 1. 9 is 1, 0, 1, 1, 1, 0, 1. And B, 48. 0, 1, 0, 0, 0, 0, 0, 0. Then I'm ANDing 1, 0, 0, 0, 0, 1, 0, 0, 1, 0. So the result in the A will be 4 and 8, 48. That will be a result in your accumulator A. The same thing, you can replace this with R. And you can replace with XR. But only thing is, we don't have any instruction for not. Only one is there. That is called, you can say, complement. Accumulator. That is called not accumulator. They call complement. That means that A not A bar is equal to A. Sorry. A bar. For example, if you say that move immediate A, 79. If you say complement accumulator, then 0, 1, 1, 1, 1, 0, 0, 1. It will become 1, 0, 0, 0, 0, 1, 1, 0. So the thing is that once we complete all the instructions, it is easy for us to write program. Okay, that's why I told you I thought that today I'll take a few instructions. And as we discussed, actually, add immediate, subtract immediate, add with carry immediate, subtract with borrow immediate. And we also have it called here, and immediate, or immediate, XOR immediate. So we have those, all the immediate instructions also there, which you can refer that document, and it's all available in the net. The only thing is you have to understand, somebody have to tell you the things, how easy it is, nothing. Now they have one more extra thing. That is a trick. I have already told you that repeatedly, all these instructions if you understand about our microprocessor discussion, all these operations, that is your ALU operations, that is addition, subtraction, multiplication, which we don't have it. We don't have it. And we have AND, OR, NOT, and XOR. Okay, so these instructions are performed between registers only, not with the memory. So if you see all our discussion with about registers, but sometime you may like to do with the operation with the memory. Let's say I have a memory. I wanted to have a location of 75, the location 1000. I wanted to add this with my accumulator. Let's say I say move immediate A, 12 H. Let's assume everything is hexadecimal. I want to add this. I can do like this. Let's say move immediate B, 12 H. Load accumulator with 1000. Now add B. See that? This is possible. So now what I do here, the B is 1, 2. And you are loading accumulator with from 1000 H. 75. Then you are adding. One zero one, 101, 101, 000, 101 carry, 110, 1, 1. You got this. This is in A now. Because add B means B plus A. Put the result in A. Am I right? Now the trick here is this address have to be stored back. You can say now once again, store accumulator at 1000 H. Now this to add, the value can be stored here. What is stored? 1 0 0 0 0 1 1 1. That is stored 87. It is possible, but they are given a one more instruction now. It's for our convenient. How do you use it? I'll tell later. There's a convenient. Here you have a 75. I can put move immediate H, 10 H, because 10. Move immediate L, 00 H. Now H becomes 10, L becomes 00. There's an instruction called move A, M. There is no register called M. In your entire 8085, wherever you see M means, you know what is M? It is M of the address pointed by H and L. But let us say, for example, you say that, now I say that move immediate A, 10 H. Add M. Add M. That means that what I'm trying to say is that this microprocessor ALU taking the value from accumulator and taking a value from memory and adding. But I previously told that this is not possible because ALU does not add from memory. So what they do, the microprocessor manufacturer, when you do this instruction, add M, they move the value of M of HL to temp. They move to temp. Then they will do add A plus temp. Put the result in A. So there is a register called temp register inside the temporary register, which is not, you cannot access. You cannot say that move immediate temp, comma 5. You cannot do that. They don't show it to you at all. So whenever you do the move instruction, it takes a HL. Okay. What is the advantage of this? I will tell you now. I'll tell you now. Then you will know that. We have instruction called like add, subtract, and, or, XR. Like that. There is an instruction called increment. If you put increment A, it will increment only the A. If you put increment C, it will increment C. But increment L, it will increment L. If you increment H, it will increment H. Like that, we have an instruction called decrement. So we have increment, that is plus plus, minus minus. That's what exactly the increment decrement. The thing is that it saves lots of your time. That means that otherwise you have to do add, move immediate, add, and everything. So, for example, I say that I want to increment register B. Let us assume that I want to increment register B. Okay, I say that move immediate A, comma 0, 1. Add B. Move A to B. See that? I have to do this. Whereas in this case, if I say increment B, done, is a 1 byte. Here 1, 2, 3, 4. 4, I have to take 4 instructions from the memory, and then I have to execute. This type of instructions will save your time. Okay. That's why when you write a program, if you write a program I plus plus, I is equal to I plus 1. That makes different. When you do I plus plus, when they convert to assembly, they will use increment. When you do I is equal to I plus 1, okay, they will use this. So the assembler, this is called optimization. Okay. That's the reason they have the, when I can do add, then I also have a, why should I have an increment and decrement? That is to save your time. Okay. Like that. There are instructions called like this. For example, I have an instruction called move immediate A, comma 45H. Am I right? Move immediate H, comma 10H. Move immediate L, comma 00H. Now what happened? H become 10, L become 00. So HL becomes 1000. But there is an instruction called, okay, LXI. Load extended. X means extended. Load extended immediate H, comma 1000. You can directly give. Now what will happen? The 10 will be stored in H. So this is equivalent to this. I could use this system. Why I have to have this? That's a trick. You understand? So when this is possible, why the people have given this instruction? There are 2 reasons. One is I can understand easily. Second one is I can able to save the space. This is only 1 byte, and this is 2 instruction. Here it is 1, 1, 1, the 4 bytes. I have to read the 4 bytes, and I have to execute this separately. I have to execute this separately. Here there's only 1 execution. Understood? So they have this flexibility. These things will save the time. That's called optimization. So they could that's like this. You can have a LXI B. B means BC. LXI D. D means DE. That is what we have a confusion. The problem is there is no right way. This is the way I did not have to use at all. I can use this. Both are same. You cannot, if you ask me that, why I have to use this, I don't have a reason. These are all given by the manufacturer. You can use it. We always, when in the colleges, you will be always having a happy mood to use various instructions and find out what is the result. Same way, like here, see here. Decrement, increment, they have a INX H, INX D, INX B. That means that if I say INX H, they will increment 1001 together. INX X means extended. All X represents extended. Okay. Like this, there are a few instructions. For example, they have a instruction called exchange. What happened? It's a very funny instruction. DEHL will be exchanged one byte. If you have to do this, how do you write a program for this? I want to exchange. I want to see, let us say DE is having 1, 2, 3, 4. HL is having 4, 5, 6, 7. I want to move the 4, 5 here and 1, 2 here and 6, 7 here and 3, 4 here. How many instructions you have to write? But I can do it in one instruction. XGHG, done. I can, this what happened? This becomes 1, 2, 3, 4. This becomes 4, 5, 6, 7. This is a 1 byte, one single byte instruction that 80 yeah, DEHL. No, you do not have to give DEHL. Okay, let me check once again whether I forgot or not. Let me check. Okay, thanks. Somebody else. Like this, if you this is all my 30 years of experience. This one memory. I'm not doing it now. Let me check the data sheet 1 minute. Sorry, please. I want to prove it to you that now itself the data sheet. X. Yeah, this is not this. The instruction is XGHG only. Exchange HL and DE. It's nothing. We do not have to specify that that other one. The instruction itself is only 4-letter word. You need not have to specify because by default, XCHG means HL and DE only, not other instructions. Okay, so no, what I'm trying to say is that go and read the documents. You have it that if you don't understand any instruction, let me know. I'm always available. But if you don't put the effort of this, then there's no point in attending and discussing. Watch this. You have a time of week to discuss. Come back and tell me that these are all I don't understand. That's fine. There are some few specific instructions called DAD. Okay, this is a very, very nice instruction, which will be very useful. For example, if you say DAD B. Okay, one thing I forgot. It's DAD with respect to what? I forgot. 1 minute, please. Sometime I forgot it. Thanks. Sorry. I don't memorize and come here. Let me, since I have a data sheet, I thought I'll refer it in a minute. You can also refer it what I'm doing. It same thing. I like you here. DAD. See here. Add register pair to HL. It's HL is a reference here. In the case of DAD, if you put DAD B, Yeah, it's there on net. I also just searched before coming to the class. I searched. I'll share the thing. I'll share this. I'll share it now itself. Which is way later. I will prepare a PPT and send it to you later. Right now, I'll share this one. This is somebody's one. Okay, it's that. I just first, this is the first one came when I searched today morning. Okay, that B means like accumulator. If we say that is it D means, if that B means BC plus HL, put the result in HL. That D means DE plus HL, put the result in HL. Always HL is a very, see, when you start writing the program, then you will understand the power of the processor. You can do anything. You can literally do anything. It's all your imagination. Then you will understand the C very, very easy. That's the way we learned C. That's why I told you, even though at the age of 37, I was learning C. But fortunately, that college days, my assembly language programming helped me a lot. Like that. So we have move instruction and move immediate instruction and add instruction like that. Like that, we have a register called M always. When there is a M means, if I say move M comma A, that means this is equivalent to store accumulator 2000. That I can say that LXI H. Thousand. See, LXI H 1000, move M comma A. I'm moving A to M. Now I'm doing store accumulator 1000. Both looks to be same. But now I tell you what is the advantage of here. I can say here, increase INX H. Now H becomes 1001. I can say that move B comma M. Then I'll say INX H. I'll say move M comma C. I say INX H. Move M comma this one D. I just have to increment only. Otherwise, what you have to do? You have to do that. Move M comma A. If you do the store, you say that store accumulator 10,000. 1000 H. Then you say move A comma B. Store accumulator 1001 H. Move A comma C. Store accumulator 1002 comma H. Move A comma D. Store accumulator 1003 H. This is also same. But you need to understand that why they have given a various techniques. That's the thing. So all you have if I ask 10 people to write the assembly program, all the 10 will be different. 1 to 10. All the 1 to 10 will be different. Okay, that's a trick. There is no method you can write only this way. Correct, exactly. That's what I'm saying. LXI is like a pointer. Okay, this is you are incrementing the pointer. If we say LXI H comma 1000 H, that is equivalent to pointer equal to 1000. Sorry, 0x1000. Then you say PTR plus plus. Here it is increment H. Both are same. Okay, somebody could be able to find out. That's compare the thing here too. That's the way. This is what doing the same thing. If you go and see the instruction in 8086 or 8088, you will find the same things. Nothing great. Okay. So if you have any thing on the instructions on move, for example, there is an instruction called DAA. I don't know how many of you have used it. Okay, this is a very, very tricky instruction. This is a very tricky instruction, which is, you heard about something called BCD. That's called binary coded decimal. For example, in my case, if I say 1001, sorry, 100 0111. If I add 1 to that, it becomes 1000 1000. It's clear because 1 plus 1 0. I add 1 here, 1 plus 1. Now think, if I have this 100 1001 and I add 1 to it, what will be the result? Quite simple. 1 plus 1 0. I had 1. 1 plus 0 1 0 1 0 0 0 1. Am I right? So 8 9 plus 1 is equal to 8A in binary. But if it is a BCD, 89 plus 1 should be what? 90. So what the microprocessor will do, if you give this instruction, let's say you do this, you put DAA, then what that guy will do, he will check this bit. Oh, this guy is above 9. Above 9. Then what he will do, he will subtract that 9 here. Okay, you'll subtract that 10. Now, when you subtract 10 here, this becomes 0. And add 1 to it, it becomes 9. That's called DAA. Now this becomes 90. This is not possible in your binary. Otherwise, you have to write a program to convert this. You have to check every time. Oh, this guy is above 10. Then you have to add this. This is called what? DAA, a special instruction. Decimal adjust accumulator, BCD. That's for, you heard about BCD number. That is for this. Then add 6. That's correct. Add 6. Perfect. That's a perfect thing. Add 6 is the right logic. Okay. So somebody has gone through the 8085 so well. That's fine. So this is the way that works. And this is a normal program. But sometimes these programs are using only ALU. You do ALU and move instructions. But the actual power of this processor is decision making. It's a decision making. So what are the decision making? It's basically, there are 2 types. One is called jump. Let us say I have an instruction 0000, starting address, move immediate A, 75. Okay, now I'll say this takes 2 bytes, 2 bytes, 0002. I say move immediate B, 46. Okay, then I'll say 0004 because this takes 1 byte, this takes 1 byte. That's why I put 2. Then I will say increment A 0005. This is only 1 byte. Increment B. I'll say jump jump to 0, 0. That way I go to jump here. I'll do this, this, then go here. Do this, go here. I can jump to 4. That means that I can go anywhere. The address 16-bit. My 8085 is having a 16-bit address line. So I can jump to anywhere in my code from anywhere. But the only problem is when you jump, nobody knows from where you have come. If you jump here, you don't know from where you have come from there. Okay. This is like go to in C. Jump. But the jump itself I can show. For example, let's say that I wanted to increment this guy till the B becomes 0. Now I say decrement B, increment A and decrement B. But the jump will only jump always. But I just put here jump if non-zero. See here, jump if non-zero. Understood? That's why we have a flag called 0 flag. When I decrement B, that will set the flag now 0 because this is 46. If you decrement by 1, it will become 45. Since it becomes 45, the flag is not set. Since it is 45, the flag is set to 0. Then it will go back because I told him jump if not 0. Go back. Then come back, decrement. Then it becomes 44, still 0. It comes like that. After 45 loops, it becomes 0, 1. When it comes here, when you decrement, it becomes 0. That time, the flag will be set to 1. This is a use of flag register. Now, our man will check, oh, I told him to jump if not 0. Since it's 0, he will come down. This is like a loop. You do it now. Char I 0. Then you will start checking. You will say char I is equal to 46. Go to, let's say, loop. Okay. If I is less than I is equal to 0. You are checking I is equal to 0. Do this. That's what this. Then you say I is equal to I minus 1. Then go to loop. So you write this, that if you compile it, it will become like that. Okay. This is a way the compilers work. The compiler takes your C code and then convert it to this type of code. That's why the colleges, when you do 8085, this is nothing. It's not complex. They are trying to test you that. Can you be able to see? I have been given like this. I've been given 1 rupee, 2 rupee, 4 rupee, 8 rupee coins. For example, we have it. I ask you to give you 14 rupees. I ask you to give 14 rupees. So you give 1 8 rupee, 1 4 rupee, 1 2 rupee. Oh, you have this. You want this. Can you be able to match or not? This is what the simple thinking. The same thing I have this. You know that I don't have a multiplication. I don't have a multiplication. In 8085. 8085 has only addition and subtraction. I want to multiply 75 by 35. How do you do that? Simple. You say move A, comma, say move C, comma, move immediate C, comma, 75. B, comma, 45. I'll say move immediate A, comma, 0. I move A, comma, 0 first. So I moved 0 into A. Then I move C 75. And I moved B 45, 35. I multiply only this. Then I'll say here add what? So let me put here D. That will be E here. Okay, I'll tell you why it is. I'll also initialize with move B, comma, 0. I put zip B 0. Yeah, I'll do that. Now I'll say add C. I'm adding C. Okay. You understand now? I'm adding a C. C is having 0 now, 75. A is having 0. I'm adding now. I'm decrementing. B. B is 35. Sorry, D is decrementing. Decrement D. I'm decrementing D. Since I'm decrementing D, I put jump if not 0 to once again add. I say add C. I'm adding A and C. 75 and A, I'm doing that. And keep on adding. Jump if not 0 to I go back here. 005, for example. This is 0 means, let me write the exact code. Move immediate A, comma, 0, 0, 0, 0, 0. Oh, it's top. Let me write it now very clear. Move okay. Now I do that. Now I'm trying to add now. Add A, comma, C. So 0 plus 75. A becomes 75 now. I'm decrementing. What? D. Jump if not 0 to where? This is 0, 0, 0. This is 0, 0, 0, 2. This is 0, 0, 0, 4. And this is 0, 0, 0, 6. This is 0, 0, 0, 8. 0, 0, 0, 9. Because this takes only one instruction. 0, 0, 0. 9 plus 1, 10. A, 0, A. This is what dies in the memory. When the microprocessor executes, it'll do this. Now jump if 0 to where? I'm going here. But it keep on doing this. There's one problem here when I do this. What is happening now? When I'm doing this, adding the C and adding the C. I am 75 plus 75. Next time when it comes, it becomes 5 by A, 7 plus 11, 14 EA. That is fine. But when I am adding next time EA and 7, 5, 10 plus 5, F, 14 plus 7, 21, that becomes 5F. But you get the carry. In this case, we don't handle the carry at all. Yeah, You are right. You're perfectly right. Okay. We don't have a carry at all. You know what I'm doing? I am taking the, every time when there's a carry comes, I have to add, that's why I use B. B becomes 0. Am I right? I am going to add with the B. So use, yes, there can be any method, but I'm using one instruction here. I say add C, then I say that add immediate B. But that time A will get damage. So how do I do that? Now, whenever the C becomes, whenever I'm adding the add C, I get a carry. Whenever I get a carry, I have to increment the B. How do I do that? I can think of it, but if you could able to think it is fine. If somebody could able to come out with the code, it's very nice. Can anybody can come out with the code? What is that? Add carry. Then what? How do I decrement the D? If I jump to where? Oh, jump to here. Jump on carry to jump. What is the instruction? No carry. All right. Is it right? What I have just tell me only a few. See, I have to decrement every time. I have to decrement because I'm adding now 75 plus 75 plus 75. I'm adding how many times? 35 times. Understood. Now D has to be decremented. That's why I have a decrement D. So after this, before decrement, D, I have to have some instruction. What instruction? Is there instruction called JOC? It's a jump on carry. Is that? Let me see this instruction. Check. What are the instructions we have it on a jump? Yeah, this was the condition. You know, you have a no carry is there. Jump on no carry is there. Do you see the screen? No 0, 0. Non-zero, 0. No carry, carry. Parity odd, parity even. And positive and minus. Jump with positive, jump with minus, parity. There are only 8 conditions. Each one is dependent on one flag. 0 flag means non-zero. Carry flag means carry. And parity flag is for parity odd and even. And this flag. Now tell me, how do you do it here? What will be the code you write here? I can write it, but I want some of you to try this. How do I write a code here such a way that when I add carry, I get a carry. If I get a carry, I should increment B. Otherwise, I will lose the information at all. I don't want to lose the information. So, let me take a break for 2 minutes and come back. Okay, think about it in the meantime. In the meantime, think about it and what code you will write here and send it to me. That is only you can send to me on the private message, direct message, not to be on public. What code you will write here? Such a way that it should decrement and go proceed. But in this place, If the carry comes, I have to increment B. If a carry don't come, I do not have decrement. They send me the code now.